Hello everybody, welcome to Anushka Tech YouTube channel. Let's continue with yesterday's class. We'll solve today few more problems related to trigonometric ratios. Okay, let's start with the question number 1. In a right triangle ABC, right angled at B, if tan A is equal to 1, then verify that 2 sin A cos A is equal to 1. So what they have given is there is a right triangle ABC which is right angled at B, and they have given tan A is equal to 1. We are supposed to verify that whether 2 times sin A cos A is equal to 1. Okay, let's draw the right angle triangle as usual. So this is our right angle triangle, right angled at B. ABC is our right angle triangle. So what they have given is tan. So and the angle of reference is A. By definition we know that tan is nothing but opposite by adjacent. So here opposite is BC. So 1 divided by 1. When nothing is given here means I can take it as 1. Okay. So 1 and 1 we need to find the side AC. Then again we'll proceed with Pythagoras theorem. So that is what AC square is equal to AB square plus BC square. So AB is 1 and BC is also 1. So it is simply 2. Therefore, we got the value of AC as root 2. So this value is how much? It is root 2. Now we'll write down sin and cos. So by definition we know sin is nothing but sin A is equal to opposite by hypotenuse. So that is what BC divided by AC is equal to how much it is now? 1 divided by root 2. So similarly for cos. So cos is nothing but adjacent by hypotenuse. So that is AB divided by AC. So it is also same 1 divided by root 2. Now let us consider the given term, given 2 times sin A into cos A. So 2 into sin A value is how much it is? 1 by root 2. Cos A value is 1 by root 2. So is equal to 2 into 1 divided by root 2 into root 2 will be root 2 whole square. So the square and square root will cancel. It will be just simply 2 into 1 divided by 2. 2 will cancel is equal to 1. Therefore, we verified that sin 2 times sin A cos A is equal to 1. Hence verified. Okay, it is so simple. We just need to understand the problem, what they have given and what we are supposed to find out. We need to write down the given entities so that we can find out whatever has been asked. Okay, next we'll proceed with problem number 2. So the question is, in a triangle OPQ right angled at P, what OP is equal to 7 centimeter and OQ minus PQ is equal to 1 centimeter. Determine values of sin Q and cos Q. So we are supposed to find the value of sin Q and cos Q. I think in yesterday's class we have solved a similar kind of problem. Anyhow, we'll solve this one also. Okay, now let us draw the right triangle. So what is the triangle is? Right angled at P. So let us take this as OP and this one as Q. So it is a right angle triangle OPQ right angled at P. So what they have given is OP value as 7 centimeter and they have given OQ minus PQ is equal to 1 centimeter. So what we will do is, let OQ minus PQ they have given as 1. What we will do is we will take OQ as 1 plus PQ. Okay. Let us take OQ as 1 plus PQ. Now as per Pythagoras theorem it becomes OQ square is equal to OP square plus PQ square. Okay. So OQ value is how much it is? 1 plus PQ whole square. So OP value they have given how much it is as 7 square, and we will write PQ as it is. So let's expand this. It is 1 plus, it is like A plus B whole square. A square plus B square plus 2 into A into B. So is equal to 7 square is 49 plus PQ square. So this PQ square and this PQ square and LHS and RHS, they will cancel each other, because if I take this towards LHS, it will become PQ square minus PQ square, anyhow it is 0. So 1 square is 1 plus 2 into 1 into PQ is 2 times PQ is equal to 40. So let's shift this one to the RHS. It becomes 2 PQ is equal to 49 minus 1, which is nothing but 48. Therefore PQ will be how much? 48 by 2 is equal to 24. We got the value of PQ as 24. But what about the OQ value? OQ is nothing but 1 plus PQ. So 1 plus 24 will be the value of OQ. Done. So we found all the sides, OP, PQ as well as OQ. Now what they have asked for us to find out is sin Q and cos Q. By definition we know that sin Q, they have asked us what? Sin Q. So this becomes our angle of reference. So the side in front of angle Q will be the opposite side, and the side which is part of it is the adjacent. So now OP is the opposite side, okay, and hypotenuse is OQ. So it is OP by OQ. It is nothing but 7 divided by 25 centimeter. Done. Similarly for cos Q. So cos is what? Adjacent by hypotenuse. So that is PQ divided by OQ. So it is equal to 24 divided by 25 centimeter. Hence we found the value of sin Q as well as cos Q. Guys, the problems are very simple. You just need to remember the definitions of the trigonometric ratios, and also you must know some what algebraic identities like a plus b whole square, a minus b whole square, and also you should be knowing what? Pythagoras theorem. If you don't know Pythagoras theorem, it becomes very difficult for you to solve the problem. Done. So next we'll go with the third question. So what they have given is, consider triangle ACB right angled at C, in which AB is equal to 29 units. 29 units means it can be meter or centimeter. Okay. So BC is equal to 21 units and angle ABC is equal to theta. So we are supposed to find the values of cos square theta plus sin square theta and cos square theta minus sin square theta. Now let's draw the right angle triangle as per the given problem statement. So it is right angled at C. Done. So it is A, C and B. So ACB is our right angle triangle. Done. In which they have given the value of AB as 29 units and the value of BC as how much? 21 units. And ABC. So this value is how much? It is theta. We are supposed to find these two values. So they are given two sides. We are supposed to find out the third one. Again we'll start with Pythagoras theorem. According to Pythagoras theorem, it is AB square is equal to AC square plus BC square. We want AC square. So what we'll do is we'll send BC towards AB. So AC square is equal to AB square minus BC square. Okay. So what is AB square? AB value is how much it is? 29 square. BC value is 21 square. So let us write it as AC is equal to square root of 29 square minus 21 square. So doesn't it resemble the algebraic identity A square minus B square? So A square minus B square is nothing but A plus B into A minus B. Why we are writing it is to simplify the calculation. A plus B into A minus B. Because every time there is no compulsion that we have to remember the square of all the values. Look at 29 square, sometimes we may or we may not remember. So in that case these identities will come to our rescue. Okay. So A square minus B square is A plus B into A minus B. So it becomes so simple now. So 29 plus 21 is, I think it is 50. Okay. 50 into 29 minus 21 is 8. So it is nothing but square root of 5 is 40. So that is 400. So this answer, how much it becomes? Square root of 400 is 20. Okay. So therefore AC value is how much we got as 20 now. Next we'll start with the solving the problem. So here first one is cos square theta plus sin square theta. So cos square theta plus sin square theta. So as per the definition, what is the value of cos? So cos theta is nothing but, now this becomes what? Opposite, and this is adjacent. So adjacent by hypotenuse. So that is what? BC divided by AB is equal to 21 divided by 29. And sin theta is equal to opposite by hypotenuse. That is AC divided by AB. So is equal to 20 divided by 29. Let's start with the first one. So cos square theta plus sin square theta is equal to, so 21 by 29 whole square plus 20 by 29 whole square. Okay, so this is equal to 21 square by 29 square plus 20 square by 29 square. Let us take 29 square as common in the denominator. Numerator will be 21 square plus 20 square. So 21 square is 441. Okay, 441 plus 20 square is how much? 400 whole divided by, let us find a 29 square. So let's do somewhere here. 29 into 29, 9 9s are 81, 1 8 carry, 9 2s are 18, plus 8 is 26, plus 2 9s are 18, 1 carry, 2 2s are 4, plus 1 is 5. So 1 4 and 1 5 6 7, it is 8. Now this is equal to how much? This is equal to, numerator is also 841, denominator is also 841, so they will cancel and answer will be 1. Okay, so cos square theta plus sin square theta is equal to 1. It is a trigonometric identity which you will come to know in the future classes. So next solve the second problem. Cos square theta, already we found the value of cos theta and sin theta here, so directly will substitute, is equal to, how much it is? 21 by 29 whole square minus 20 by 29 whole square. Okay, so this is equal to 21 square by 29 square minus 20 square by 29 square. So 29 already square we have found out, it is how much? 841 in the denominator. So 21 square is 441, 20 square is how much? 400. So that is equal to 441 minus 400 is nothing but 41 divided by 841. If it is possible to divide it further, you can divide it further also. Okay, so we are done with the 3 problems in today's class, and we'll meet in the next class. Thank you. Let's start with problem number 4, and most probably this will be the last problem related to what? Trigonometric ratios. Okay, so let's read out the question. If angle B and angle Q are acute angles, B and Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. It is not like the problem which we have solved in the previous class, where we were supposed to show that angle A is equal to angle B. So now it is angle B is equal to angle Q that we are supposed to prove. Okay, that indicates, or which implies that we have 2 triangles now. One triangle is ABC and another one triangle is what? PQR. So this is, let us take this as our first right angle triangle, that is ABC. What B is? It is an acute angle. Then next PQR be the another right angle triangle. So this is P, Q and R, right angled at R. Okay, so we are supposed to show that angle B is equal to angle Q, and we have drawn 2 triangles ABC and PQR. You can observe the size, the shape is same, but their size are different. So how can we prove these two angles are equal? In the previous problem there was only one triangle where we are supposed to show the two sides are equal. If they are equal, then their angles were also equal. Now we have two separate triangles and we are supposed to show these two angles are equal. It is possible only when we prove these two triangles are similar. Okay. If both the triangles, that is the ratio of their corresponding sides, if they are proportional, then their corresponding angles will be equal. What we are supposed to show now? We are supposed to show the ratio of their corresponding sides are proportional. Okay. So let's start with the problem. Okay, let's start with the solution for the given problem. So what they have given is sin B. They have given is what? Sin B is equal to sin Q. Okay. So let us take this as equation number 1. We need to find out what is the value of sin B. So sin B is equal to the angle in the side in front of angle B is, now this is what? The opposite side. So that is what? AC divided by hypotenuse is AB. And sin Q for triangle PQR. Now this is the opposite side and this is what? The hypotenuse. So that is what? PR whole divided by PQ. Okay. Sin B is equal to AC by AB. Then sin Q is equal to PR divided by PQ as per equation number 1. Now wherever sin B is there, okay, then in place of sin B I have to write AC divided by AB. In place of sin Q we are writing what? PR divided by PQ. Now let's rearrange this like this. Okay, we'll write it AC by PR is equal to AB divided by PQ. That is ratio of this side and this side is equal to ratio of this side and this side. So let us take their value as some letter called as K. Okay. Now next what we'll do is we'll find the this side. Okay, that is BC value, because already we have taken the ratio of these two sides, right? So only side that is remaining is BC in triangle ABC and RQ in the triangle PQR. Let's apply Pythagoras theorem for triangle. For triangle ABC, AB square is equal to what it is? AC square plus BC square. But I want BC, right? So BC square is equal to AB square minus AC square. So this is equal to what? BC will be simply square root of AB square minus AC square. Now for triangle PQR, it is PQ square is equal to PR square plus RQ square. I want RQ, right? So RQ square is equal to PQ square minus PR square. RQ is equal to simply square root of PQ square minus PR square. Done. So next we are supposed to take ratio of these two sides. Now that is BC divided by QR or RQ, anything is okay. It is nothing but square root of AB square minus AC square whole divided by square root of PQ square minus PR square. Now what we'll do is we'll go for a substitution. We'll substitute AC as well as AB in terms of PR, PQ as well as K. Let AC is equal to K times PR and AB is equal to K times PQ. Okay, as per the given condition. Let us take this as equation A. From equation A. Okay, now let's substitute here. So square root of, in place of AB I am going to write K PQ whole square. In place of AC we will write K PR whole square whole divided by square root of PQ square minus PR square. So this is equal to square root of it, now it will be like k square pq square minus k square pr square whole divided by square root of pq square minus pr square. So in the numerator k square is common. If we take k square outside the square root, it becomes simply k square root of pq square minus pr square whole divided by square root of pq square minus pr square. This numerator and denominator, they will cancel each other and will be left with only q. Or that is bc whole divided by qr is equal to k. K is also equal to what? AB by PQ. It is also equal to AC divided by PR. Therefore, what we have shown that the side AC by PR is proportional to the side AB by PQ is proportional to the side BC divided by QR. So it is nothing but triple S criteria, side criteria. If this is satisfied, then the triangles, this implies what? The triangle ABC is similar to triangle PQR. Therefore, angle B is equal to angle Q. When the triangles are similar, the corresponding angles are equal. Okay. With this, we are done with the problems related to trigonometric ratio. See you all guys in the next class. Thank you.